Welcome to Zebra Aurora Vision Studio. In this tutorial, we'll take a closer look at the deep learning OCR, learn how to use the related filters, and demonstrate different features of this tool. Let's start from explaining what deep learning OCR is and what differentiates it from the traditional OCR algorithms. Throughout this tutorial, we'll be focusing on the DL-read characters filter, which is the main tool used for the deep learning OCR. This filter is capable of locating and recognizing multiple characters within the image. Compared to the traditional OCR tools, it does not require any time-consuming training and comes with a set of OCR models ready to use and pre-trained using a vast range of different font samples. Our deep learning OCR can deal with difficult OCR cases impossible to solve using traditional methods, such as damaged, distorted or blurred text, as well as characters on reflective and complex non-uniform backgrounds. So, without further ado, let's jump to our sample program and start learning. Let's build a simple program to check how does the DL-read characters filter work. We need an image source, so let's start from acquiring some images from the film strip. We can add the DL-read characters filter now and connect it to the image source. Additionally, we can use the merge characters into lines filter, which helps in initial characters formatting. We'll add it by pressing the Ctrl plus spacebar shortcut, which opens the filter search. To speed up our program, we can load the deep learning model before the first iteration. It's always a good idea to do so and add the DL deploy filter to the initialize section. If you can't see this section, please click the sections icon in the program editor. Please also note that we won't be setting any regions of interest. This way, the filter will recognize characters from the entire image area. Let's run our program now and set up the previews. We'll use one preview for the graphical data and another one for textual. As we can see, the OCR recognized the text without any issues instantly. It would be great, however, to have all characters in one row as a single string, instead of separated from each other. To do that and join characters on the same level, we need to increase the in-max gap parameter of the merge characters into lines filter. It looks good now. Let's proceed to another image. We have a bright text on a dark background here, but as we can see, this polarization did not cause any issues and the text was recognized properly using the automatic settings. We can of course change the polarization ourselves if needed. Our deep learning OCR can read text printed using dot matrix fonts, even if the contrast is not good enough. Moreover, it can recognize text printed or molded on plastic surfaces, engraved, etched or punched on reflective metal surfaces, as well as text on complex backgrounds or unevenly illuminated surfaces. As we can see, our tool performs very well without any additional adjustments. Sometimes, however, it needs a couple of tweaks here and there. The first thing we usually check is the character size. The filter looks for characters with size similar to the value specified in the in-char height parameter. If the size of the characters in the image differs too much from this value, the results might not be correct. To check the actual size of the characters, we can use the measure distance tool. We will see that the actual height is much bigger than the default in-char height value. We will increase this value only slightly, because we still want to be able to recognize characters in previous images. We've changed the size and everything looks fine now. Another parameter we often adjust is the in-width scale. If the characters are unusually wide or narrow, we can play with its default value to compensate for this difference. The next image is quite challenging because the text is printed on rough, transparent surface with some bright spots and shadows. What's more, it contains some less frequently used characters that are not recognized by default. This can be adjusted using the in-char range property, and by default, the DL read characters filter is looking only for letters, numbers, slashes, and dashes. It's not a big deal though, you can add other characters yourself easily. Let's set it to auto for now. Now everything is recognized, but there are some errors. Namely, there is an extra dot at the end of the first line. This is because the polarization is set to any, and the filter is looking for both dark and bright characters. That's why some of the white spots are interpreted as dots. We can correct it by changing the expected polarization to dark, increasing contrast threshold to remove low contrast results, or simply increasing min score parameter to get rid of the low score readings. Let's make a quick test and see if our settings will let us read characters in every single image in the dataset. As we can see, this powerful tool recognizes all characters properly. This concludes our tutorial. If you want to learn more, please take a look at our technical documentation available at Zebra Aurora Vision Developer Portal. You can find links to the sections of the documentation relevant to this tutorial in the video description below. Thank you for watching. For more information on Zebra Aurora Vision software products, visit us at aurora-vision.zebra.com.